This is 4.4, Add and Subtract Fractions with Common Denominators from OpenStax PreAlgebra. And we're going to be focusing on Section A, Model Fraction Addition, and Section B, Add Fractions with a Common Denominator. So before we jump in, let's go ahead and take our readiness quiz. Pause the video, work out these three problems, and then unpause it to make sure that you got them correct. So let's go ahead and simplify these. Well, number one, we're simplifying. Number one says 2x plus 9 plus 3x minus 4. So we're simplifying, which means that we are going to be combining like terms. So remember, when we combine like terms, anything that has the same variable with the same exponent, we can combine together. So we can rewrite this as 2x plus 3x, and then numbers that don't have variables can also be combined together, but if there's a negative, that negative needs to travel with that number. So plus 9 minus 4. Okay, so then this, we can combine the x's. 2x plus 3x. Remember, the x stays the same, but we add the coefficients. 2x plus 3x is 5x. All right, and then we have 9 minus 4 is 5 plus 5. So the simplified version is 5x plus 5. Next, draw a model of the fraction 3/4. We've done this before, and so you could do fraction bars or fraction circles. I'm going to do fraction circles because today we'll be working with circles. And so I draw my circle and I divide it into this many pieces. However many pieces are in the denominator, that's how many pieces I divide it into. So I need 4. But then I only want to indicate 3 of those. So I'm gonna color in 3 of those. 1, 2, 3, and it doesn't matter which 3. And then I have drawn a model of 3/4. If you were to do it with fraction bar, a fraction bar, it would look like this. Okay, you divide it into 4 pieces, and then you would color in 3 of them. So these are equally valid ways of drawing a model of fraction 3/4. But like I said, today we're going to be working with the circle ones. And then simplify 3 plus 2 divided by 6. So remember, the fraction bar acts as a grouping symbol. So we have to do everything on the top and then everything on the bottom and then put them together. So let's simplify the top. 3 plus 2 equals 5. And the bottom is already simplified. It's just a number, 6. Okay, so we've simplified the numerator. And then we need to check, can we simplify this entire fraction? No, we can't, because there's no number that is a factor of 5 and 6 other than 1. So that is the simplified version. If you did not understand why the answers are what they are, let me know. I can refer you back to previous lessons to cover these. So let's move on to section A. Oops, sorry, got my control panel there. Okay, so section A, model fraction addition. We're gonna visually look at what's happening when we're adding fractions. So how many quarters are pictured? Well, you guys know how to count, right? There's 1 quarter, there's 2 quarters, and there's 3 quarters if we're talking about a whole quarter. But remember, 1 quarter is 1/4 of a dollar. That's why we call them quarters, because they are a quarter of a dollar. So we have that's 1 quarter, this is 1 quarter, and this is 1/4 of a dollar. But notice they're split into 2 groups, and so we could also say that if we have these 2 groups, we have 1 quarter, and then here we have these 2 together, 2 quarters. Okay, 1 quarter and 2 quarters. And so then we can add those together. So we have 1 quarter plus 2 quarters, and that equals 3 quarters. Okay, so one thing that you need to note is that you add the numerators, right? But the denominators stay the same. You still have quarters. No matter how many of them you have and you're adding, you still have quarters. Okay, so the denominator stayed the same. So that's visualizing it with quarters. Let's go ahead and visualize it with with fraction circles. So we're going to do the same thing with fraction circles. So if each one of these represents a quarter of a circle, I'm going to try my best to draw these accurately. I don't make any promises. Okay, so this is, if this is 1/4 of a circle, what I'm trying to do is draw just one of those sections, but it didn't turn out right. Okay, so 1/4 plus 2/4, and we know that 2/4 would look like this. Okay, and you could do any of the 2/4. Okay, and then if we want to add these together, so we get 1/4 plus 2/4, and then we put those together and we get, let's see if I can do this, it's kind of Pac-Man-ish. There are our 3/4. Okay, so this was 1/4 plus 2/4 equals 3/4. Okay, so we've visualized 1/4 plus 2/4 with quarters themselves and with fraction circles. And this is what you're going to be doing in section A. You're going to be making models of fraction addition. Let's do an example. It says use a model to find the sum 3/8 plus 2/8. Okay, 3/8 plus 2/8. So let's see what a circle looks like when divided into eighths. Okay, so if I put one line, that's halves, fourths, and then I need to divide each of those again, and there's eighths. Okay, so it should look like this. Now, if we were doing this in the classroom, I would physically give you pieces of circles, pi wedges, in order to do this. I can't give those to you through the computer, and so you're going to have to visualize this. If it helps you to cut out a circle and cut it into pieces, please do that. If it helps you to move them around, which I know some of you, it would be very helpful to do this. So first, we need 3/8. Okay, so 3/8. So we're going to take, let's see, I'm going to use orange for 3/8. If we do 1, 2, 3 for our 3/8, so I'm going to try to draw that. Okay, so here's our 3/8, and then we are going to add 2/8. I'm going to choose a different color. Let's do pink. And then we need to add 2/8. 1, 2. Okay, so I'm going to sketch that. Plus 2 of those. And then I'm going to put those together to find my final answer. So I'm going to put that together with blue. So I have my 3/8 and my 2/8 put together, and that equals 1, 1, 2, 3, 4, 5/8. Okay, so we have 3/8 plus 2/8 is equal to 5/8. So that's how when it says use a model to find the sum, that's what you are doing. Okay, so now I'm going to give you a few try it problems to find the sum. So we're working with 8s and we're working with 6s. Let me go ahead and quickly sketch out what those would look like. So we just did the 8s. 8s would be, you divide it in half and then in half and then divide each of those in half. So this is 8s. And then for 6, you're going to divide it in half, but then here's where it gets a little tricky because you have to divide each half into 3. So we're going to go here and here. It doesn't have to be perfect, just approximate. And so this is 6. So this is what you would use for this one down here. So pause the video, use a model to find the sums, and then come back. So let's go ahead and do 1/8 plus 4/8. So I'm going to pick this as my 1/8, so I'm going to sketch that in there, 1/8. Okay, and then I'm going to add 4/8. 1, 2, 3, 4. So I'm going to sketch that out. That one's kind of easier to draw because it's a half circle, and then divide that into 4, like an orange, like a wedge of an orange. And then I'm going to sketch all of those together. So, like I said, this would be a lot easier if we were in class doing it together and I was handing you pieces of triangles, but close enough. We'll make do with what we have. So we have 1/8 plus 4/8, let me get my symbols in here, is equal to 1, 2, 3, 4, 5. 5/8. Okay, and that's how you would model 1/8 plus 4/8. 4/8. Okay, let's do 1/6 plus 4/6. So up here we're looking at 1/6. There's 1. So I'm going to sketch that. 1/6. And then we're going to add 4/6. 1, 2, 3, 4. So that takes up almost the rest of it. So all the way around to the top like this. And that's 4/6. Okay, so we have 1/6 plus, oops, not 4/6. 1, 2, 3, 4/6. Now we're going to put them together into one shape. So here we have our 4/6 plus our 1/6, and that equals 1, 2, 3, 4, 5. 5/6. Okay. Okay. Check yours. Make sure yours looks like mine. If not, go back and watch the explanation. So now we're moving on to section B. Section B is add fractions with a common denominator. A common denominator means that the numbers under the fraction bars are the same. So hopefully that's not new to you, but let's talk about what that is formally. So fraction addition. If A, B, and C are numbers where C does not equal 0, then A divided by C, so the fraction A over C plus B over C is equal to A plus B over C. Okay, so this is how you do fraction addition when you have common denominators, right? They both have C on the bottom. The bottom of both fractions is the same. You add the numerators, right? A and B are your numerators, so you add them and place the sum over the common denominator, C. So you do not change what's on the bottom of the fraction. C is on the bottom here, C is on the bottom here, C is still on the bottom here. Okay, you do not add the denominators together, you leave them the same. Okay, that's very, very important. So let's do an example together. 2 examples. Find the sums. Okay, so we have 3/5 plus 1/5. So what do we do first? Let's go ahead and put our steps up here. First, we add the numerators. Those become our new numerator, and then we keep the denominator the same. We keep the common denominator. Okay, so let's go ahead and do this. So add the numerators. We have 3 plus 1. 3 plus 1. And we keep the denominator. This is a 5, this is a 5, so it stays a 5. But then we can simplify this. So let's simplify. 3 plus 1 is 4. Keep the same denominator. Okay, 4/5. Now, can we reduce this? No, we can't. 4/5 is reduced already. Now, this one throws in a variable, but we still do the same thing. Do not let a variable scare you. Okay, so we're going to add these two together on top of the fraction because they are the new numerator, x plus 2. And then we keep the same denominator, 3, 3, so this is still a 3. Okay, so on the first one, we then simplified by adding those two together. But we can't add an x and a 2. We don't know what x means, so we just leave it like that. That is your final answer for this problem. Okay, so do not get scared when there's a variable there. You still just add them together, put the sum over the common denominator. Okay, you're going to do a couple try it problems. You have the one on the top, it has just numbers. The one on the bottom has a variable as a numerator. So pause the video, try these, and then come back and see if you did them correctly. So the first one, we're going to add the numerators, 3 plus 2. Keep the same denominator, 6, 6, this becomes 6. Then we'll simplify, 3 plus 2 is 5. Keep the same denominator, 5, 6, that is not reducible, so this is our answer. Okay, and on the bottom, we're going to add the numerators, y plus 5, keep the same denominator, 8, 8, 8, and we cannot simplify this because we have a variable, so this is our answer. Okay, check your answer, make sure it matches with mine. So here, now we have a different scenario where we have a variable as the denominator. It does not change anything. We do the same process that we did before. So let's go ahead and do this. Another thing is we have a negative out here. Okay, so we're going to put that negative with the numerator. Remember in a previous lesson we learned that negative 9 over d is equal to negative 9 over d, and that's also equal to 9 over negative d. Okay, so it's easier to work with the negatives when they are with the numerator. So we're going to do that. So let's change this to negative 9 over d plus 3 over d. Okay, so all I did was I moved this negative sign and attached it to the 9. Okay, and so now we're going to do the same thing. We're going to add the numerators. So we have negative 9 plus 3, and keep the same denominator, d, d, d. Now we have two numbers on the top that are added, so we can simplify those. Negative 9 plus 3 is equal to negative 6, and we keep the same denominator, d. Negative 6 over d. Now, like I said, there are multiple ways to write this. I don't mind if you leave it like this, and I actually prefer to leave it like that, but if you want, you can put that negative back out in front and put negative 6 over d. It's up to you. It doesn't matter to me. Okay, bottom. Now we have variables in both fractions. Let's see what that looks like. We do the same exact thing. We add the numerator. No matter what's in the numerators, you add them. 2n plus 5n. And we keep the same denominator, 11, 11, 11. Now, we can simplify the top, so let's go ahead and do that. 2n plus 5n equals 7n, and we keep the same denominator, 11. 7n over 11, and that is your final answer for that one. Okay, so do not let the fact that there are variables there scare you. Okay, you're going to do some try it problems. Pause the videos, try these, and then come back and make sure that you got them correct. Let's work these out. So first thing I'm going to do is I'm going to move that negative up and attach it to the 7. Negative 7 over d plus 8 over d. Okay, now I'm going to add the numerators. Negative 7 plus 8, and keep the same denominator, which is d. And then I'm going to simplify the top. Negative 7 plus 8 is positive 1. And on the bottom, I still have a d. So it's 1 over d is my solution here. On the next one, 2q plus 7q is 9q. And keep the same denominator, which is 5. And I cannot simplify this. There's nothing that divides evenly into 9 and 5. So this is my final answer. Check yours and make sure yours matches mine. One more variation here, and that's when you have a negative on both fractions. A negative on both fractions. So we're going to start out the same way. We're going to move those negatives up to the numerators. So let's make that negative 3 over 12 plus, move this one up here, negative 5 over 12. Okay, and then we follow the same procedure. We're going to add the numerators. make sure you take the negatives with the number they're attached to. Negative 3 plus negative 5, and we keep the same denominator, 12, 12, 12. But now we can simplify. We have all numbers in the top, so we can simplify. Negative 3 plus negative 5. If you want to think of it that way, you can do that. Or you can think of it as negative 3 minus positive 5, right? You can rewrite it that way. So whichever way, this way or this way, you prefer is fine with me. Either way, you're going to come up to the same answer. Negative 3 plus negative 5 is negative 8. And we keep the same denominator. Same thing down here. Negative 3 minus 5 is negative 8. Keep the same denominator. Okay, but then we can reduce this, right? 4 divides evenly into 8 and 12. So 4 goes into 8 2 times. 4 goes into 12 3 times. And you're left with negative 2/3. Same thing down here. 4 goes into 8 2 times, 4 goes into 12 3 times, and you're left with negative 2/3. And then once again, if you want to, you can pull that negative out and say it's equal to negative 2/3. It's up to you. It doesn't matter to me. Okay, so one more try it problem, maybe two. One more try it problem. Pause the video, work this out, and then come back and make sure you did it correct. So first I'm going to move those negatives into the numerators. Negative 4/15 plus negative 6/15. Add the numerators. Negative 4 plus negative 6/15. Once again, if you want to rewrite this as a minus, as a subtraction problem, that's fine. Negative 4 plus negative 6 is negative 10 divided by 15. Now I need to check, is this reducible? Yes, it is. 5 divides evenly into 10 and into 15. So 5 goes into 10 2 times, 5 goes into 15 3 times, and I'm left with negative 2/3. And if you want, you could rewrite it as negative 2/3. Up to you. Doesn't matter to me. Okay, so check your answer, make sure it matches mine. If not, go back and rewatch the explanation. If you need help, please let me know. Check Google Classroom for your assignment.